Let's look at number 1. Also, I had one of those moments where I was doing this on Wednesday, and I was like, why did they name these functions E of t and L of t? And like it hit me like midway through the problem that E is because it's for the rate at which the cars enter, and L is for the rate at which the cars leave. I know, right? I was like, man, it's a good thing this is not a reading test. So I failed. Okay. Now that's a lot going on in that function there, E of t. You've got a constant. You've got, you're going to multiply t times t, and you even got, just for fun, you've got the natural exponential e, right? There's a lot going on there. But luckily, this is a calculator question, so I don't have to really do anything with that unless it's in a calculator. It says we're looking at t between 0 and 12. So my thought was that we're talking about 5 a.m. All right, 12 hours from that. What's 12 hours from 5 a.m.? No, what's 12 hours from 5 a.m.? 5 p.m. What up, Raquel? That's a life lesson there. 12 hours, just the same number, right? Awesome. It says, what is the rate of change of E of t at time t equals 7? So this is essentially saying, do you know what it means to do in any problem when it says the rate of change? The derivative. The derivative. Yes, that's not how you spell derivative. All right, so I'm going to use the calculator to find the derivative, and then I need to evaluate that derivative at 7. Now, you're going to see that because I'm using this calculator, I'm not going to use t, I'm just going to use x. So where it says t, I'm just going to use x. All right, it's the same thing. No worries there. All right, so get your calculator if you haven't got one yet. Make sure you turn it on. Remember, if you want to start fresh, because my stats kids were using some of these, you can go ahead and hit second plus sign and reset the memory if you would like. It's your choice. Oh, I feel like I need to get a new Chromebook. The charge has been running out quickly. How often should I replace a computer? What's the going? 8, 10 years? All right. Well, this is only year 6, so I guess I got a ways to go.
Does it have a fan?
A fan? No, it's like a tablet type computer, so it doesn't have a fan. I guess it might. I mean, it gets hot, so it has something to cool it down. All right, so if you're trying to clear it out, hit second, plus sign, reset. Wait for it. The Wi-Fi has been really good today. So that was second, plus sign, which is memory, then number 7, which is reset, all the RAM, come on screen, and then reset. All right. Ready? All right, click math. Click math. And then go down to number, what did I say, derivative? Number 8. Number 8 is the derivative. Come on screen. There it is. See number 8? Number 8 is derivative, so hit number 8. And we're going to type it in. This is d dx of, all right, the first thing was 3, right? Plus, nope, is it 3 times? No, 30. Is it 30? I already forgot. Is it 30?
Yes.
30. Is it 30 plus?
Yes.
Okay, and then I think it's x minus 2.
It's 5.
X minus 5? Nope.
5.
Oh, goodness gracious. 30 plus 5 times. Okay, I got it. Nope, that ain't it. Plus 5 times. And then it's x minus 2?
Yes.
Okay. Then it's x. So I got to do this. I'll get you the e in a moment. Is it x minus 5?
Yes.
All right, here's how you do the e. So to do the e, how come I can't delete that thing? Oh, that's because I put the parentheses around 30. That's okay. All right, and then E, you do second natural log. Second natural log is E. The ln for natural log. Second ln is E, and then I think it's negative 0.2x. Sure, I'm going to get an error message. But you want to evaluate this at t is 7, right? I think that's right. Let's see if it works. Did you get it?
59.
It says quit.
It says quit. Just quit.
What did you get?
I don't know. I'm about to hit enter. This is nerve-wracking. Second natural log. Second ln. I'll give you the E. Yeah, ln is natural log. What did you get, Jasmine?
I got 6.62.
That's it. Go to. Hey, go to. Maybe there's like a parentheses wrong.
Now it's frozen.
Let it go. Yeah, I think so. It has it.
It's frozen.
I don't know what it is.
Okay, well, the answer is 6.165. Someone write that down. 6.165. Now, let's talk about the units of measure because it made a big deal here, 165, right? Do you remember what the unit for E of t was? Let's do this. Units for E of t. What in a problem it tells us what the units is for both of these? Do you know what the units are for E of t? Cars per hour. Was that what we're got? Sick. It is cars per hour. Okay. So if we do a derivative, a rate of change, do you know what that's going to do to these units? Because it's got to be different than cars per hour. It throws on, it doesn't flip it, it throws on another per hour. So they put on the, yeah, sorry, go ahead.
Why is EMT cars per hour, but like on the graphics, like label LMT is cars per hour?
They're telling you the rate at which the cars enter is E of t. So it's not number of cars, right? Because it would say the number of cars that enter is modeled by this, but the fact that it says the rate, so that's why it's cars per hour. And L of t is also in cars per hour. That's what this is showing you, right? So I don't, the key, right? Checking my notes, the key says cars per hour per hour. I think that's silly, all right? I just remember my days in physics that I would just put cars per hour squared. That's what I'm gonna put. But if you wrote cars per hour, that's right too. If I did what?
Cars per hour per hour.
Yeah, right? I mean, like, who does that? Get on. The moment I read that on the key, I was like, oh man, I love calculus. Like, why would you do that? Any questions on A? There's a lot of technology there, right? So it's one of those things, if you type it in wrong or your calculator makes a mistake, you didn't make a mistake, I think. Well, you said the calculator made a mistake, and I'm just not sure how that's true. All right, let's do letter B. All right, letter B. How many cars enter, that's a key word here, enter the parking lot from time t equals 0 to t equals 0. So essentially between 5 a.m. and 5 p.m. All right, so this is why I really wanted you to focus on the units. Remember, what is the units for E of t? Cars per hour. So if I want just cars, what am I going to have to do here? Who knows what we're going to do? Something way more complicated, some calculus involved. The integral. We got to back up a step, right? So I know it's weird for like PVA, but right now we're at the middle one, right? When we just found the derivative, we went to the second one, the per hour squared. But if we want to back up to just number of cars that are entering, we've got to take away the rate, which means to go backwards from a rate, backwards from a derivative is the integral. So this is the integral from 0 to 12 of E of t. Whatever that is going to give us the number of cars that enter the parking lot while it's open, 5 to 5. All right, everybody okay? All right, so let's go to the calculator again. Hit math. So math again. Did somebody write something not appropriate?
They said change batteries, and then they said lazy. That's how they said.
Number 9 is the integral. Somebody probably wrote that like 8 years ago. That's amazing. Number 9 is the integral. We're going from 0 to 12. And I'm going to literally just type in what E of t is, which I'm sure I already forgot. 30 plus 5 times x minus 2. I don't know why I said I forgot. It's literally right above me. Woo! Got excited there. Here we go. All right. Just as you're typing this in, when you have limits of integration, like that 0 to 12, what type of integral is this called? When you have limits of integration, the 0 and the 12, what type of integral is this called?
What does it start
A D.
with? What's the question?
I'm asking, if I drew the integral symbol and I did not have
Oh.
limits of integration, it's called this type of integral. This one is different. It has limits of integration.
Does it start with a D?
It does start with
How many letters? It was the second letter.
starts with an E, or the next letter is an E. The next letter is an E. It's definite. Thank you. Right, and if it doesn't have limits of integration, indefinite. There we go. Indefinite. Okay. Well done.
I think she deserves a ticket.
I did.
All right. So what are we saying is the number of cars that are going to enter this? Did you get it this time, Annie?
No.
Oh my goodness, no.
What?
And that's a new calculator. So I have 2 calculators that don't work.
Apparently.
So how many cars am I expecting to enter? Awesome. And I'm just going to round. It looks like it's 520. So 520 cars.
I think you finished the problem.
I think we have another part, but yeah, we finished part B. So 520 cars. This is number 1, right?
Does it get harder?
Oh yeah. Number 2 is harder, and then just wait till we get to the ones without a calculator there. So there's gonna be a section next week when I'm teaching you, and I'm just gonna hand up, say I don't know how they got this. The key is not helpful. It gives you some work, but it doesn't show you all the work that they did. And I can't figure out how they got this number without using a graph. So it's a question you can't use a calculator, but I could go to Desmos and show you. So I'm gonna go to Desmos and show you how it is this. I don't know. That's the first thing I'm gonna ask. Day 1 of my AP Summer Institute, I'm gonna ask the professor, can you show me how this number is gotten? Because it's frustrating to read a solution key and to not show their work.
Yeah.
For the teachers. Stats is super detailed about how they find stuff. It's really frustrating. Anyway, everybody good on B? All right, let's do C. I think, does this have C and D? Yes. Oh man, awesome. All right, this one is, this is the one that I got right, and I was really excited. Okay, I'm very excited. All right, this is gonna be tricky. Okay, so notice now we're switching.
She got it wrong too.
It's something about that side of the room. We're switching to L of t. Okay, So now this is just talking about the cars that are leaving, right? And it does say we're going to use a trapezoidal sum with 4 subintervals indicated by the data in the table to approximate the integral from 2 to 12. So that would be 7 a.m. to 5 p.m., the rate at which cars are leaving between there, okay? Now, here's what I did, all right, to figure this out. I know that I need to do a trapezoidal sum, all right? So that means I want to see what this looks like when I graph it. Now, you could use the calculator to type it in, but I think we can just draw a quick little sketch. So just write really small, okay? And what's the first ordered pair from the table? So it says 215, all right? So I'm going to plot, just again, this is just made up, right? 215. Everybody still with me? That's 2 comma 15. Wait for it. There it is. Just from the table. So the rate at which cars are leaving at 7 a.m., Raquel, is 15 cars per hour. Okay? What's the next one? The next ordered pair? 5 and 40. Okay? After that? 9 and what was it? 24. Thank you. I think they said 24? Yep. The one after that? 11, I think? 68. Okay. Okay, and then the last one was 12, 18, thanks. All right, everybody still with me? Again, just a sketch. Now watch what happens when I draw the lines, like the vertical lines down from these ordered pairs. Ready? What did I just create? Not just one trapezoid. Not just 2 trapezoids. How many? Multiple. I like it. There you go. I created 4. All right. So to find the area under the curve, which this problem is asking you to find the integral from 2 to 12 of this function L of t, that's literally just saying find the area under the curve. And I know these aren't curves, like they're all lines, right? But essentially, if I find the area of each of these trapezoids and add them together, that is called a trapezoidal sum. All right. So one of the hardest things about this problem is, do you know the area of a trapezoid? I'm not going to do that because I think that would be more challenging. It's 1/2 times base 1 plus base 2 times the height. And if you wanted to do base 1 plus base 2 times the height all over 2, that's fine as well. It's your choice. Okay? So let's see. I'm going to change colors to help your brain. I'm going to try to zoom into my sketch. There we go. And see if we can get this stuff. Okay, ready? Okay. So the way I want you to think of this is weird here, but all of my heights are going to be horizontal. I'm going to repeat that. All of my heights are going to be horizontal. All right? So do you see how this first point is 2 in the x value? What's the next x value of the next point? 5. So what's 2 to 5? That would be 3. So this height is 3. Yes, because going from 2 to 5 gives me 3. Just flip your paper. You can do that too, right? Whatever you want. Now my bases, all right, bases are going to be this. See if you can make sure. Do you want me to switch colors for bases? Would that be helpful? Let's see. Okay. I'll use blue for bases. So this base is going to be 15, and this base is going to be 40. Let me see how I got that. Okay. This next one is going to be a base of 40 and a base of 24 with a height of 4. Because I'm going from 5 to 9. Wait for it. Wait for it. There it is. Okay. The next one has a height of 2, 9 to 11. The bases are 24 and 68. And the last one has bases of 68 and 18 with a height of 1. So all I did now from this point is once I know all this information, I'm just going to use my area of a trapezoid formula to find all 4 of these. All right, so I'm going to do 3 times 15 plus 40 times 1/2 plus 1/2 times 4 times 40 plus 24 plus 1/2 times 2 times 24 plus 68. And finally, the last one has a height of 1 times 68 plus 18. So if I find out what this is going to be the same as the integral from 2 to 12 of our L of t function. All right, so once you have this, you're just going to go to your calculator and type it in. Be careful, Eddie, when you type this in. So I have 0.5 times 3 times, what was that? 55 plus 0.5 times, was it 4 was the next one? Yeah, times 64 plus 0.5 times 2 times, oh, what is that? That's going to be 92. 68 plus 24, 92. Yeah, 92. Plus 0.5 times 1 times, what is that? 86. Here we go. We ready to press enter? Oh my gosh. Sorry, it's freaking out. Wait for it. There it is. Yay? Yes! Look at that. We got one. Didn't involve calculus, so that helped. All right. Now, I'm going to write this down. All right, 345.5. But you need to make sure you explain or put the units of what this means. Remember, we're going backwards, right? The antiderivative of the rate at which cars are leaving this parking lot. So if we go one back, right, we're backing up, what does this mean? Remember, L of t is here with the rate at which cars are leaving per hour. If I back up, that means I'm just chopping off the per hour. And this just means cars. So this is how many cars I expect to leave between 7 a.m. and 5 p.m., right? 2 hours after 5 a.m. is 7 a.m. So 7 a.m. to 5 p.m. So that's what I'm going to write down. I'm going to write down, I expect to see approximately 346 cars leave between 7 a.m. and 5 p.m. All right, everybody okay with C? All right, one more part for this problem, and then we'll finish the first problem. right, so part D says that they actually change their price for how much you have to pay depending upon the time that you enter the parking lot, which is, if you've ever been to like a parking lot downtown Houston, where that's pretty standard, right? Depending on the hour you're going in, or maybe more of like, it's not actually that, it's more of how long you spend in the parking lot, right? 1 hour, 2 hours, especially like an airport parking lot. Okay, so this is saying from 5 a.m. to 6 hours after 11 a.m., they're charging $5 from each car entering. And then if you enter after 11 a.m., or at 11 a.m. until 5 p.m., you're getting charged $8. All right. So how many dollars are collected from the cars entering the parking lot from time t equals 0 to t equals 12? So it says entering, right? So I'm focused on EFT again. All right. And in order to do this, I need to know how many cars. But EFT has what units? Excellent. So if I want to go back to cars, or back up from that to get to cars, what do I have to do? What calculus term? The integral. So this is really two integrals, right? You have the integral from 0 to 6 of E of t plus the integral from 6 to 12. Now, to make this more efficient, I'm going to put my stuff in now, but I've seen students who do this also will do this first, and then they'll take the numbers and multiply them by the prices. But to make this like official, how much money am I charging from 5 a.m. to 11 a.m.? $5. So I put a 5 in front, right? Because I need to multiply all that by 5. And then how many dollars for 11 to 5 p.m.? $8. Okay, so you can actually literally just type this in all in one fell swoop in your calculator. But I worry, so we haven't had success yet, if this is going to work out. Let's see. Okay. Here we go. So it's 5, and then click math. Number 9, 0 to 6. 30 plus not 4. You guys want me to pause halfway and like get a number? Or do you want me to just do it all at one time? I think it'd be easier to see it if I do this one first. Like hit enter. Okay. Right, so that's just from 5 a.m. until 10:59 and 59 seconds. We're expecting essentially $1,051. So I'm going to do the same thing now, but do 8 in front and going from 6 to 12. So here's 8 times that. 2 for 2, said Lolly. Nice. Joel, you got both? Good for you. And then we're going to add them together. Now, I'm not sure. I think your calculators have this capability, but if you scroll up and click that and hit enter, and then hit plus and scroll up and hit this one, hit enter, you should be able to do that, I think. Yeah? All right, so we're saying that all this added together, we expect this parking lot to make $3,530. I think it said, did it say round to the nearest dollar? I think it did. Yeah. So $3,530. All right, guys, that's number one. Just so I hope that this is going to work, I'm going to stop the recording right now.